You've probably already heard of atoms before. They are small units of matter that form the things around us. You may be also familiar with the parts they are made of. The nucleus has positively charged protons and neutrally charged neutrons with negative electrons around the nucleus. However, we can zoom in further on a proton or neutron and find even smaller particles. In general, these smaller parts of matter are called fermions. But wait, you may be asking how we can prove such tiny particles exist. In particle accelerators, particles can be launched at high velocities. If we shoot a particle at a proton at random angles, the particle will deflect at a different angle each time. This means that there are smaller particles within a proton that are deflecting at different angles depending on where the particle lands. The parts of a neutron or proton, also known as hadrons, are specifically called quarks. So far, six quarks have been discovered. The two we are concerned with are the up and down quarks. Both protons and neutrons are made of these two types of quarks in different configurations. Protons have two up quarks and one down quark, while neutrons have one up quark and two down quarks. Since protons have a charge of +1, these quarks must have fractional charges. That means an up quark has a +2/3 charge, and a down quark has a -1/3 charge. What about the other four quarks? These quarks are more massive versions of the up and down quarks. The up, charm, and top quarks all carry a +2/3 charge, but the final two are too unstable to exist for very long. The down, strange, and bottom quarks all carry a -1/3 charge, but the same thing applies to the negative quarks as the positive ones. Now let's see how electrons fit into the picture of fermions. It turns out that the electron itself is a fermion. That's right. Electrons are far less massive than a proton, so much so that they are considered fermions themselves. However, they fit into the second category of fermions, called leptons. Electrons, muons, and tauns all are progressively more massive than the previous, and all have a -1 charge. There are three other leptons called neutrinos, which, hence their name, all have no charge. I will not discuss them in detail in this video, but I will cover them later. So, in total, we have 12 fermions, including quarks and leptons. We have seen how quarks and leptons have built the atoms all around us. There is another category of elementary particles, but they do not make up matter like fermions do, but instead they play a different role. This will be our focus in the next video.